In this lesson, I'll discuss database security. By the end of the lesson, you'll be able to discuss the certain database elements, explain database access control, and understand how database security is threatened overall. First of all, what is a database? A database is any structured collection of data that is accessed by one or more applications. Databases are usually stored relationally, meaning that items are linked to each other. For example, we have student data at the university. Student data includes a lot of different information. You would be shocked at how much information that we need to store in a student. So things like name, birthday, student ID, and address are probably commonplace among any other university out there. Healthcare data: name, birthday, patient ID, address, doctor, data visit. That's probably also standardized across the healthcare industry. How about website data? A lot of websites have databases, and we may store the name of a person, their username, password, email address, and secret questions for password recovery. These in relational databases all relate to some component of each other. So name, for example, we can match the name with a birthday. So that's why when you call your doctor's office, they say, what's your date of birth and what's your name? You give them those two pieces of information and they know exactly who you are. Now, the chances of you actually having the same birthday as somebody else are pretty large because there is a lot of people on the earth, but the chances of the combination of your birthday and your name and the doctor's office that you're calling are pretty small. However, they do relate to the database overall. Database elements. Most databases, like I said, are relational. The columns within the actual database are going to be used for particular types of data. The name, for example, is a column that all the records, which we'll call rows, are used for. Rows are unique values for a primary key. And what is a primary key? Well, the primary key is something that that can uniquely identify you. So, for example, student data. Your unique or primary key is probably your student ID. Nobody else is going to have that student ID. In the US, we have Social Security numbers. This uniquely identifies you to you. But associated with a name, associated with an address, associated with employment if you're under Social Security. So primary keys are going to be something that is unique. Foreign keys are something that is linked to either a primary key or something else that links you to, or that entry to, another piece of content in the database. For example, a major from a student. So for example, my major when I was in my undergrad was computer science. And then it switched to business, and then it switched to information technology. However, at least that was able to identify a little bit more information than just my name, for example. Now, if I had my student ID, which is the primary key, that would have been much better to have, but my foreign key also tells me something that I can search on that may be unique. Other database elements include the language that we use to access the database. Now, even though a lot of different database software companies use somewhat their own language, it's usually all made up of a single language called SQL. You may have heard it referred to as SQL. This is the structured query language, SQL. It provides a way that we can look at data no matter what software that we're using, nearly every software that we're using for databases. And finally, the DBMS, which is short for Database Management System. The DBMS consists of a database, the users, and the tools that are used to manipulate the data and the database. Access control. This is where we see threats into the database. Most SQL languages and programs give two types of different access. We either can grant access or we can revoke access. We also have rights. Rights allow us to do different things with the data, and depending on whether we grant or revoke access, they allow us to do a few different things. The typical ones that we're going to see are select, insert, delete. It's also called drop, if we want to drop some data or delete data, and then update as well, which is modification to the data. Now that's pretty much standard across most databases. Some databases also have role-based access control built in. This is RBAC, role-based access control. Microsoft mainly looks at this in a completely different way, because the Microsoft operating systems are built around role-based access control. Role-based access control is used to increase security. So we're going to give somebody a certain role to manage the database or to do different things with the database. And this can be much more granular than just our read, write, and execute rights. This can be put on almost anything. So if we want a user just to maintain the, for example, the student database versus the administrator database versus the employee database versus faculty database, we can do that with different roles. So examples of this include database owner, database administrator, or system administrator, as it's in database language it's like to be called. In fact, Microsoft SQL uses for the overall super user access, it's called the SA account, or system administrator account. You also have end user roles, or maybe even reporting services. Perhaps that you may want your database to report certain things. Well, they have to have a role too to access information in the database. So why are databases so important, and why do we have to talk about them here? We're talking about threats in computer security. Organizations really live off of databases. They hold a huge amount of information. They contain customer information, financial information, and security information as well. Most of the data breaches out there have involved some type of data breach where we get into databases. So this could be email databases, financial databases again, anywhere where we're seeing overall collections of data, and how we're updating those is really important to look after. So database security is very, very important. There are quite a few threats to database security. The largest one is going to be SQL injection. SQL injection usually happens off of web applications, and the goal is to extract information from the database. It is one of the most common type of attacks on databases. It's exploited through insecure web applications. And if the application has enough permissions, the attacker can do almost anything that they want with the data, including deleting or modifying the data. Think about this in financial terms. What if I wanted my bank account to have $50 more in it? Well, if I use SQL injection, maybe I could actually insert $50 more. Another type of threat is inference. Inference is really explained as an attacker can use one or more queries to infer the database structure or the content. So if I'm pulling information from one database and looking at another database, I can infer maybe that two things exist. So let's say that we'll pick something that two very different things. So somebody that lives in a certain zip code and somebody that we know lives around or goes to school in that same zip code. We can infer that the person that goes to school in a zip code actually lives in that zip code. So we can infer data based on matching quite a few foreign keys together. This usually occurs when too much access has been given to a user, where maybe we can look at one database and then we can look at another database, but we don't have all the fields or we don't have access to all the fields. Encryption. Encryption is a threat because a lot of database administrators don't encrypt their databases. So what happens if we have SQL injection? Well, that would be stealing data out of the database. So if encryption were on the database, maybe they won't be able to get much data out of that database. So an attacker might grab unencrypted data if the encryption is not performed over the entirety of the database. Encryption becomes essential to secure data. A lot of the really, really bad data breaches out there are caused or made worse by a lack of encryption on the data itself, and that is in the form of database encryption.